This is Studio 12 TeamJ, and we were assigned one-handed lifting. We were assigned the task of one-handed lifting, and for this assignment, we had to create an efficient and safe support for one-armed people in wheelchair, more specifically for use in the kitchen. During our meeting with the client, we took note on some of their struggles when cooking, which propelled us in the right direction to begin brainstorming product ideas. The constraints that we felt were most important and had to be tackled were the lifting strength of their arm, which was about 5 pounds when raising to the front, as well as how they have to place their items on their lap and hug them to transport them across the kitchen. And lastly, not being able to get under the countertop makes mixing, cutting much harder. Ensuring that we met these requirements as a group was crucial for us going forward. Firstly, we planned on having a pivot hinge, which helps in bringing the table upright. This also helps as the table can be tucked to the side when not in use to save space. Next was to add a 10 milliliter syringe to the end of the tubing contraption. This is so when the client pushes down on the two 150 milliliter syringes, the end of the syringe will act as a piston and push the wheels forward to start moving the table up. Next, we wanted to add a cutting board to be the top of the table. This is so the client can do all their cutting and mixing on top of it instead of using a countertop, which can sometimes be tricky to use if the height is not right. We also wanted to add a track system for the wheels. That way they're fixed in place and move smoothly along the material. The wheels, along with a middle pivot point, were supposed to be attached with axles. That way the whole contraption moves in unison. We wanted to add a stopper to the start and end point of the wheels. That way the client can measure the distance that they want the table to move up and down. Due to recent events, we were unable to integrate some of the parts we had planned, and we have to use a prototype for the demonstration. For a full run-through demonstration, the pivot hinge would bring the desk up to the top of the chair. From there, it would be brought down and rested on the opposite armrest with the other hinge. Next, the client would press the lever connecting the two syringes, ensuring they move at the same speed and distributing the same amount of fluid to the wheels. The tubing would then be connected to a 10 milliliter syringe, forcing the wheels to move forward as a piston dynamic, ensuring the table moves upwards.
Some of the engineering solutions that went into this project are our lifting mechanism, some linear actuators, and some safety measures that would be implemented when the project is complete. So firstly, our lifting mechanism is a scissor lift. It essentially works by moving this point in relation to this point, allowing the entire apparatus to move upwards or downwards, lifting or lowering anything placed on top. So we're using this system to create a more stable base for our table that's lifting up and down, which will allow the user to lift heavier objects more safely, essentially. Now, the linear actuator that we're using is a piston, well, actually it's two pistons that allow us to create a mechanical advantage for the user without the need for any powered pneumatic systems. Essentially, by pushing on a small piston with a smaller amount of force, it will create a pressure inside the system, and that same pressure, when applied onto a larger surface area, will apply a larger force. So essentially, 1 psi here will still be 1 psi over here, but now it's applied onto 10 square inches, allowing for 10 pounds to be lifted. Now, this would be applied to the scissor lift by connecting the larger piston from that point to that point, and when the smaller piston is depressed or allowed to open, it will change this distance, lifting the entire mechanism. In addition to these, an additional safety measure will be added, which will be something similar to an accordion sleeve wrapped around the entire apparatus. This will prevent anything from getting caught in the machine and can also keep a person safe when they're reaching around it, as if it's closing and someone's hand is caught inside, could be dangerous.